Okay, so the empirical formula is the simplest formula of the compound, and it consists of symbols, subscripts, and the numbers of each element. The subscripts represent the smallest whole number ratio, and ionic compounds are already in its empirical formula. So, for the first example, we're going to take methane, which is CH4, and this is already in its lowest form. You can see C6H24, and that reduces to C, and then H4. And another one we do C18H72, and then that also reduces to CH4. So CH4 is the empirical formula for methane. And then you can get percent composition from the molecular formula. So we're going to say we have 16 grams of CH4, and 75% is the carbon. So we're going to take 0.75, which is 75%, times 16, which gives us 12. And then we're going to go back through and double check. And then we're going to divide 12 grams by 16 grams, and the grams will cancel out, and multiply by 100, and that gives us 75% of the carbon. And we're going to do that same process again for the hydrogen. Take 0.25 times 16, that'll give us 4, so that's the number of grams we have. And we're going to divide 4 grams by 16 grams, the grams will cancel out, multiply by 100, and then we get 25% of hydrogen. They're the same because they have the same empirical formula. We could do this with C6H24, and that's 72 over 96 grams. Multiply that by 100, we still get 75% carbon, 25% hydrogen. They're the exact same. They don't change because their empirical formula is the same. You can also use percent composition to go from the empirical formula. So if you have 88.8% of copper and then 11.2% oxygen, you can divide 88.8 divided by 63.55. That'll give you 1.397 moles. And then you multiply the grams by the grams, so the grams will cancel out. So there's 63.55 grams of copper per mole. And we're going to get 1.397 over 0.7 and divide by 2. We got that 0.7 because we divided by the atomic mass divided by the mass of the substance to get 0.7. That's how we got the 0.7. And then we divide by that to get the 2. And then for the O, we follow the exact same process, and we get 1. And this would give you C2,1 oxide.